packed days of lots of insights, different viewpoints on a wide range of topics. Uh, it's my honor and pleasure to be the moderator for the last panel discussion. Yes, the crowd is thinning out, but I guess there's some who are outside who are coming in. But ladies and gentlemen, this particular session, you may have already observed the theme of which is target net zero, the technology and energy mix. Little while ago, right before the lunch break, we had the fireside chat with industry stalwart and automotive's president and CTO, Mr. Rajan Pedkar, where we talked about the ICE, the longevity of the ICE vehicle and the emerging electrification megatrend. So we are talking about the energy mix, how it's going to change in the overall industry. So Dr. Jaura, a warm welcome once again. So, and that is also a reflection of Dr. Jaura's recognition in the Indian ecosystem, and he needs no introduction. Well, yeah, as I was saying, the energy mix, it's changing, it's evolving, and that too at a fast pace. For example, hydrogen has been a talking point for decades maybe, but it's now that it's taking a very, very special position, and also in the scheme of things of the government as well. Therefore, and that is also kind of fueling its growing importance. CNG was also being talked about. CNG again has been in the ecosystem for long, but only now it's reaching that critical scale. So, and in addition to that, different other new technologies, for example, let's say in terms of the fuel mix, ethanol, flex fuel, all are being talked about. These are not new subjects. All of them have been in existence in various forums and all in the industry. Industry players have been working on it. In fact, Dr. Jaura was responsible for developing, while during his stint at Mahindra, developing a hydrogen Scorpio. That was hydrogen three-wheeler, and yes, and he showcased one at the Auto Expo also, right? Yes, that was 2000. So these are not new topics, but it's only now that all of them are at a stage wherein they become topics of discussion from some very critical reasons, which also includes the direction in which the industry will move on from here, and also which will also influence consumer preferences. So I'm really honored to be in this position now, physically also, because I'm flanked by representatives of two ends of the automotive spectrum. On my left, Dr. Subramanian, who represents Ashok Leyland, which is India's second largest commercial vehicle maker, with a stated vision to become one of the world's 10 largest commercial vehicle makers, well on its way there. And on the other side, Dr. Jaura, who currently wears the hat of the Chief Technology Officer at not only India's, but the world's largest two-wheeler manufacturer, MotoCorp. So it indeed is a pleasure for me and a rare honor. And the audience, I would say it's a fantastic opportunity for you also to kind of pose your questions to the gentlemen. And we will soon be joined by Mr. Nishant Arya. Nishant Arya, again, has an interesting profile because JBM Auto has been a component manufacturer. It is also a contract manufacturer. Now it is also an OEM with strong interest in the commercial vehicles, particularly in the bus segment. And in buses, they have from diesel vehicles, CNG, and electric vehicles. And as part of JBM is also part of the overall kind of ecosystem, energy ecosystem, because they are also significantly invested in renewable energy. So he will bring a very interesting kind of perspective to the whole with his participation in this discussion. So we hope to have him soon in the panel. But before that, let me kind of start off this discussion with the first question to Dr. Jaura. Dr. Jaura, I mean, you're one of the few industry professionals who have seen, if I may say, the both worlds of the automotive universe, the Western world, developed Western world, and the developing countries' markets. So, and with experience, work experience in both. So, from the time when you were working on a hydrogen hybrid project during a stint at Ford to now, how much have things moved in hydrogen technology? And do you think this is where the inflection point is perhaps for hydrogen as a fuel in the automotive industry?
A loaded question. First of all, thank you, Sumantra. Thank you, ET, for inviting me to this forum and to this panel. So coming to your question, I would say, when hydrogen is not new to the auto industry. Let's sort of put that on the table first. There are OEMs that have been working on hydrogen for at least 3 decades. Okay? And they're not only, they're in the passenger vehicle space, they're in the bus space, they're also in cargo space. And that technology has been under evolution for a very long time. Now, kind of if you rewind about 20 years ago when the Department of Energy in the US, they launched a program with the OEMs. And that time you had the big three. So the big three was a cost share program, we'll make hydrogen vehicles and so on. So there was the fuel cell technology, there was also the hydrogen engine technology. And that was basically to create that impetus into the industry as well as into the ecosystem. And that's when the whole thing started. Now, if you come to Europe and you come to Germany especially, the first fueling stations were actually done in Berlin. And why Berlin? Because BMW, one of the large OEMs, as you know, was working on hydrogen engines, even for the 7 Series vehicles. So from that point to today, and yes, in the last year or the last 6 months, there's a lot of excitement, a lot of discussions about the about hydrogen. The government had actually announced, if you recall, Sumantra, the National Hydrogen Energy Roadmap. This was in the early 2000s, mid-2000s, I would say. And at that time, they had the Gen 1, now they have the Gen 2 roadmap that has been published. Now, what that does is also, again, it is to kind of energize the ecosystem in India, as well as the OEMs, as well as bring awareness to the customers and the prospective customers. So in 2008, and I'm just going to kind of make a reference to that anecdote that you mentioned, that was the first ever 3-wheeler cargo hydrogen vehicle that we had made in India. And this was not only the India first, but the Asia first and the global first hydrogen 3-wheeler vehicle. And big OEMs, when I say big OEMs, they were working on passenger vehicles, etc., some of them. And one of them is sitting here, Ashok, Leyland, Subramanian. They were all working on that. So we unveiled it at the 2008 Auto Expo. So today we are talking about green hydrogen. We are talking about creating that infra. We are looking at things. Now, have we reached that inflection point? The answer is not yet. That's a very candid answer. And because, first of all, we have to make sure that it is deployable in products that we can actually launch in the marketplace, even as demo vehicles. Even if you're doing buses, for example, you're talking about big passenger vehicles, we're commuting for, large scale. And we need mass transit to create that effect in the environment around us. So when we do that, then we are also talking about how do we create that infra. Yes, there are companies like Indian Oil and a couple of other companies who set up fueling stations. Indian Oil had set up something at least a decade ago in India, in Faridabad, if you recall, and they've set another one up. And there are various things going on. And again, this is enablers to the hydrogen economy. The affordability, I'm not even talking, and in the previous session, people were talking about affordability, price-sensitive market. Not only is India price-sensitive, every market is price-sensitive. Let's get that on the table also. Every market is price-sensitive, and whenever we actually introduce a technology, it is all about affordability and sustainability. You can give a very affordable product, but can you sustain it in the marketplace? Can you sustain it with the after sales as well? Can you sustain the supply chain? So there are a lot of aspects to that. So I'll leave it at that, and I'm going to pass it back to you.
Right. Thank you. Dr. Subramanian, staying on the topic of hydrogen, Ashok Leyland has been working on it for quite some time, and it's recently that you showcased a hydrogen engine at Bengaluru. So now, in terms of now that the engine is ready, perhaps I'm sure you must have tested in vehicles, and perhaps the vehicle is also ready. So what are the hurdles or what are the challenges for it to be commercialized, or what are the factors that need to be taken at the ecosystem level for it to become, to kind of leverage the advantages that the hydrogen vehicle, hydrogen as a fuel could provide?
Sure, thank you. Just to reintroduce myself, Subramanian, Senior Vice President. I'm in charge of advanced technologies in Ashok Leyland. I'm a scientist at heart, so my answers may be a little technical. Please excuse me for that. There's no straight answer to the question. Yes, we do have a hydrogen IC engine. You can use hydrogen in two ways in an automobile. You can either burn it in an IC engine conventionally.
The hot hydrogen technology?
Exactly. You have to make some modifications to the IC engine. It's not easy, but we have done it. The other way is to run it in a fuel cell, where you get the output straight as electricity, right? It's actually a lot more efficient, but also the fuel cell is more expensive, primarily because very few people make it. A lot of components are imported today. So to start with, those are some of the hurdles, right? So when I started looking at hydrogen, I had the same questions. I mean, there's a lot of issues. I mean, there is the cost of the fuel cell, or if you go with an IC engine, you're stuck with an inefficiency in the IC engine, right? IC engines can do today 35, 40%. There are ways to tweak it to get it to a little higher, but fuel cells kind of start off straight away at about 60%, and it can go higher from there, right? But then there are still issues with transport, with storage. It is a very small molecule. It can penetrate very small gaps, and therefore it leaks. It is combustible, so whatever leaks, you have to handle it, you have to burn it. A lot of issues like that, right? But then what I kind of convinced myself in the end was that the realization that hydrogen is not a fuel. And I'll repeat that, and I'll tell you why. Hydrogen is not a fuel. Because at least the classic definition of a fuel is that it has to have an inherent energy content, right? It has to have what's called a calorific value. So if you take a fossil fuel, a petrol or a diesel or CNG, whatever, right? It has a nature-given calorific value. It has an energy content that comes from nature. So the cost involved with that fuel is essentially extracting it, refining it, and transporting it. But hydrogen is not like that, right? You have to put in the energy, split the water, right? Or splitting something else, whatever way you produce hydrogen. I'll take the water example. You have to put in the energy. You have to entirely put in the calorific value of the fuel, and therefore get the hydrogen, and then transport it, store it, etc. And then you convert it back into water, either in a fuel cell or in an IC engine. It's the same chemical reaction, but captured in a different way, right? And then you get the energy back out of it. So to me, if you look at hydrogen like that, it actually makes a lot more sense. Hydrogen, therefore, is a storage medium. It's a battery, right? The act of splitting water to get the hydrogen, to me, is the act of charging. You put the energy, you store it. The process of storing is the splitting of the water, and it becomes hydrogen, right? And then the process of discharging is the hydrogen and oxygen reacting to form water again, either in an IC engine or a fuel cell, right? An IC engine, you burn it first, therefore a lot of it comes out as heat, it's wasted, therefore it's less efficient, right? So if you start looking at hydrogen like that, it actually makes a lot more sense. And if you look at it as an energy storage medium, as a battery, it turns out that it can actually store about 3x of what a lithium battery can store. So it's actually a great battery, it's not just a battery. Right? Unfortunately, it's about 4 to 5x more expensive today per kg. Right? So if you get the cost down, you straight away have a much better battery. And then yes, you still have to figure out the storage, transport, and all that, but there are lots of ideas coming up along those lines. Right? So this is my 2 cents. Let us change our view of hydrogen. I mean, the whole universe runs on hydrogen, right? Every star uses hydrogen as a fuel. So somewhere, somehow we're going to get to hydrogen. Of course, that is fusion. But until we invent cold fusion, we'll have to invent a different process to use hydrogen. But hydrogen is a nature-given molecule, right? I wouldn't call it a fuel yet, but a nature-given, very high-density storage medium, significantly better than what a battery can do today. And it can be, a fuel cell is just that. It is a battery. It is a battery with a slightly different membrane, with a slightly different electrode. But it's a battery where you have an equivalent reaction forming water in the end, right? And like a battery, theoretically, it is also reversible. Every battery can be discharged, it can be charged, right? I'm talking about a lithium battery or a lead acid battery. There are a few chemistries that can't be recharged, right? A hydrogen fuel cell also, in that sense, theoretically can run in reverse. And if you can do that, that's the holy grail, because then you don't need the hydrogen infrastructure anymore. You don't need to manufacture, you don't need to distribute, you don't need to store. You can plug in your vehicle, pour in some water, recharge your vehicle. Again, process of recharging creating hydrogen, right? By running the fuel cell in reverse, right? So that's my 2 cents. Thank you.
See, there you are, the advantage of having a scientist in the panel. So, well explained. Thank you very much, Dr. Subramanian. Welcome, Nishant, to the panel. It's good to have you. In fact, before we came, we were referring to JBM, its overall journey as an organization, and now with interest in the commercial vehicle industry, with not only diesel and CNG buses, but also electric vehicles. So since we are on the theme, topic of hydrogen, a question for you. Are you also looking at adding, let's say, buses that run on hydrogen fuel cell technology?
Yeah, I think
working on that.
No, I think that will definitely happen in the future. But the basic platform would be electric, and we would look at fuel cell electric vehicles. So FCEV and hydrogen both would coexist as we go along, and pure EVs as well. Because I think there is no one solution. All these different sources of technology and energy storage would coexist depending on the application in each of these cities. Because every city has a different operating model. Every customer has different requirements, whether in public transport segment, in school transportation, in tarmac applications, and intercity applications. So depending on that, the TCO will drive the technology which will get adopted, total cost of ownership. So I think definitely it is in our pipeline, and we would be looking at this technology, and we are already working on some aspects of this technology in our R&D centers.
That's good to know. In terms of the evolution of the powertrain technology, since we are talking about target net zero, there is no silver bullet, so to speak, to address the challenge, the humongous challenge that we are facing in terms of environment, and not to mention about the economical challenges of, let's say, import bills rising up and all. So in terms of the overall energy powertrain technology mix in the powertrain scenario, while there are a lot of things happening in the passenger vehicle side, on the two-wheeler side, Dr. Jaura, how do you see it evolving?
A very, very pertinent question. There are various aspects. I mean, you look at 30, 40 years ago versus where we are today. We started with the 50cc engines. I mean, I'm talking as an industry, not as Hero. Okay, so 50cc engines, 100cc engines. Just a small commute was what it was. Although you could see few people doing a longer commute. Carburetor-based engines, most of them. Then came the fuel injection. Then came the engine technologies that we could see in larger vehicles into the two-wheeler in terms of smaller engines with more power density, more energy density, depending on the kind of engine you wanted, the kind of vehicle that you wanted. Then the segmentation you see in the industry now is, and not now, when I say now, for the last few years, is the scooter segment, the commuter segment, the premium segment, and then of course the sports segment, the adventure segment. Now, if you look at these segments, the need of the customer, the need of the marketplace is what is defining the powertrain technologies in terms of not only the engine, but also the tailpipe emissions. So today we are at par, we are doing the BS6. Okay? Now we are talking about various other things that are going to be coming in the pipeline as well. So from a tailpipe emissions as well, from a recyclability as well, again, I'm sort of encompassing the powertrain as well as the entire vehicle in terms of recyclability as well. Now, the engine sizes now over the last few years have gone up. You're not looking at just 100cc, 110cc, 125cc. Today you have bikes in the marketplace which are 300cc, 400cc, 500cc, niche markets, okay? If you look at the normal distribution curve, these might be outliers, but there is a need, there is a want, there's an ask for higher power engines. And that is also making all the OEMs, Indian and non-Indian OEMs, getting into that space. Our own company as Hero, okay, we have a strategy. We are working on strategies to actually get into the marketplace. So our engine strategies, our powertrain strategies are changing to sort of dovetail into the need of the marketplace. So for example, I mean, all of you know, I mean, we have this, you know, the Harley Davidson bikes that we are actually building. We're going to be selling them as Harley as well as Hero bikes, and you will see them in the marketplace in the coming very short, I would say, short future that you're going to see it. So that is one particular aspect. We are also into other premium bike segments. We are into 220. Our X-Pulse is one of the best-selling bikes. We have the 160cc 200. So the technology in terms of bringing in a more compact engine, we've gone from air-cooled engines to liquid-cooled engines, which was not there earlier, right? So that is also coming in. The radiators were very little, very tiny. Now with the larger engines, the 400cc, 500cc engines, this is also changing. Now, how does that affect the customer? How do we actually make sure that the customer is being able to ride and handle the bike with a lot more comfort, a lot more confidence? When I'm on a bike on a road, it's very different from being in a four-wheeler or a larger vehicle. That is very, very important as well. So holistically, yes, the technology, the industry has changed quite a bit, and the sky is the limit.
Indeed, when you say the sky is the limit, and also in this age of in this disruptive era, which is highly even more than ever before technology oriented, technology driven. So, and in your case, let's say now that there's a Harley also, which is part, there's a kind of a partnership. So does that give you also opportunity to leverage synergies at the back end in terms of engineering to kind of come up with new solutions? Maybe with different energy mix also.
Absolutely, absolutely. And talking about energy mix and technology and innovation, these kind of partnerships, these kind of avenues that we are building or are building, and will be building even more, with more, I would say, proactive need, are going to give us this. And it's just not for us, okay? It's for the customer. At the end of the day, the customer is asking for different solutions. We're talking about ethanol, for example, okay? There is some discussion about methane and things like that. So we're doing the ethanol. We are also looking at flex fuel vehicles. So whatever you could see in the four-wheeler, six-wheeler, eight-wheeler space is also percolating into the two-wheeler space. And why? It's not because we want to do that. It's also because the need of the fossil fuel as well as the other energy that are available is widespread. So India as a country, the segments that you see in terms of the energy segments that you see on the western coast, on the eastern coast, on the southern coast is different as well. So can a customer that is somewhere in the south have this kind of a vehicle, this kind of a bike? Yes. When I say bike, two-wheeler, we want to give him that opportunity or give her that opportunity. The other last statement I want to make is it's also very interesting and very heartening to see a lot of female bike riders in the marketplace. Now that is changing the dynamics for us as well. Not only in terms of the looks and feel and all that, also in terms of the powertrain. And I say that intentionally because the powertrain that we are putting into the vehicle in terms of noise, in terms of the packaging of those powertrains, in terms of handling them there, is also very different now.
Oh, okay. That's also according to the customer profile also. Okay, that's interesting to know. Dr. Subramanian, since we are talking about net zero being the end target and goal, what's the kind of the ideal scenario, if I were to say, ask you, from the commercial vehicle perspective in terms of the technology and energy mix? And by the way, since we are talking about biofuels also, the government is also increasing its focus on that. What's the scope and prospects do you see for that in the commercial vehicle industry?
Okay, it's a very profound question. Net zero means a lot of different things, right? So let me take my interpretation of net zero and go with it. How do you minimize or get emissions to be zero? and to the extent possible, not use a lot of energy in the first place, right? So the analog would be, when I see a piece of electronics today, almost any electronics has a heat sink on it. I think you would have noticed. If you see any PCB which handles any amount of power, even in your audio amplifier and all that, there's a heat sink, right? What does that mean? It means heat is coming out, you got to dissipate it. So there's two halves to that problem, right? One is, why are you generating heat in the first place? Second is, okay, you had to generate some heat, but you have to somehow dissipate it so that it doesn't keep raising the temperature inside the components. But my question is the former part, which is, why are we generating heat in the first place? That is because of the inefficiency of the system, right? There is, you have a piece of electronics that's, let's say, 90% efficient, but which means 10% is inefficiency, and that 10% multiplied by the total power is what is coming out as heat, right? So we are asking ourselves that question in the automobile industry. What is generating the inefficiencies in the first place? So if we can stop it at the generation side, you have to handle fewer problems, right? So that's our interpretation of net zero. Obviously, true net zero is a dream. I mean, it's very hard to achieve, right? And I'll go back to, since I said I'm a scientist at heart, I'll go back to a little thing which most people, I think, have forgotten, right? There is this Newton's law that you learn in high school. So whatever you've done after that, I'm sure you've learned that, right? Physics professors have thrust it on you, right? So F equal to ma is what you learn. Force equal to mass times acceleration. But how many of us remember that? What does it mean? What does it ultimately mean? It means that you have a force only when you have an acceleration. If you don't have an acceleration, you don't have a force. If you don't have a force, you don't consume energy. Energy can be diesel engine or energy can be battery, right? So this is a very profound fact that physics is kind of telling you in a very straight fashion, right? In other words, let's say you're traveling from, since we are in Delhi to Jaipur, a few hundred kilometers. What physics is telling you is that to first order, you can accelerate your car in Delhi first 30 seconds, let's say 0 to 80 kilometers an hour, and you reach a speed of 80, right? And assuming there is very little traffic, assuming the road is perfect, no potholes and all that, you cruise at 80, right? To first order, after the first 30 seconds when you accelerated, everything else is a free ride. You don't consume any energy from your battery, from your engine. Because Newton is telling you, you consume energy only when you accelerate. Therefore, braking is important because every time you brake, you have to accelerate again to come to the right speed. So that is where regeneration, etc., comes. So to us, it's M and A, mass and acceleration. You need the lightest weight possible in your automobile because you're accelerating that mass. And you need to tame acceleration. Therefore, you need to tame braking also. Right? And if you do that, straight away, it's a first order effect. In other words, second order effect is your transmission loss, your air resistance, how good your tires are. It's called rolling resistance, right? But all of us seem obsessed with the second order stuff. But the move to electric is giving us an opportunity to rethink all this, right? Can we get close to what nature really intended? Nature intended a free ride for us. It intended us to use power only when we accelerate. How often do you really need to accelerate, right? If you can have a vehicle controller which doesn't allow the driver to give pickup if there is another vehicle too close so that the driver is going to anyway brake, then you limit acceleration, right? Why are we not worrying about this first order effect, which is F equal to ma, right? You tackle mass, you tackle acceleration. Right? But the move to electric is also giving us benefits in terms of the second order effects. Transmission loss is a major loss. In an electric transmission, you hardly have a transmission. You don't have the traditional propeller shaft, the traditional gearbox, the traditional differential. You don't need to have. Some versions have it, but technically you can have an electric vehicle where the transmission is a piece of wire from the battery and controller to the wheel, right? So you can remove transmission almost, right? So the move to electric, what I'm trying to say is giving us an opportunity to remove all these second order things, right? And get close to what nature really intended. So this whole notion of people thinking kilometers per liter or an electric kilometers per kilowatt hour is actually nonsense, because kilometers doesn't depend on energy. F equal to ma doesn't have distance in that equation anyway. Kilometers is not there in that equation. How often you accelerate, which means how bad your driver is, right, is the key parameter which you need to tackle first, right? So we are trying to fundamentally rethink how to redesign and take advantage of this transition in powertrain technology, how to redesign, how to get to net zero by cutting the inefficiencies in the first place.
That's a very interesting perspective, and also some very rich food for thought. Thank you. Nishant, since we are talking about energy, we have to also take in bringing into the equation the energy required to create energy to be consumed at the vehicle. And from that perspective, renewable energy becomes extremely important. Yes, India has stated its goals, so hopefully we'll be there in the stated timeline. But as an organization at JBM, you have also invested in renewable energy. So what's the scope of, what's the scope you see in terms of the share of renewable energy in the Indian kind of ecosystem, for which it will again really help the electric mobility megatrend to be increasingly be truly green?
Sure. I think that's very important, because eventually when we look at any form of energy or consumption, so one has to see that from generation to consumption, how we are talking about zero emission. Because when we talk about electric vehicles today, we are looking from the well to wheel, oil well to the vehicle wheel, how everything can be green. So it's from the tank to wheel perspective which electric vehicles solve for. So if we do not have the generation coming from renewable sources, then we are just pushing kicking the can down the road and pushing the problem out, and still generating power which would be consumed, which would be even higher amount of power in the future. But as a country today, when we are embarking on about 500 gigawatt hours of plan by 2030 of renewable energy, and most of it would be driven by solar, I think it's very important that when we are generating energy, how are we using that energy? So today, when we look at this, there are different forms of energy storage which are being used, so that we are talking about grid balancing, we're talking about peak shaving, we're talking about peak power pricing. At the same time, we are producing at a given time and we are consuming throughout the day. That's why when we see that in many countries, you see that it is grid to vehicle and vehicle to grid as well, and at different hours. So the vehicle acts as a backup to the grid when the vehicle would not be in use, and there would be peak power requirements in the city, in a given city, like in California and many other cities and states across the world. This is being done now, and it is working very well. So idea is that when you're designing any vehicle, you're designing the grid or the whole EV ecosystem. So you're starting with energy, and in electric vehicle, I see today that it's dynamic and static energy. So renewable energy plant is static energy, the electric vehicle is dynamic energy in different ways. So the batteries which are being produced, there are multiple chemistries which are being used by different players. And today we talk about battery recycling being a concern, the electronic waste being a concern, and all those issues coming up. Personally, I see that if at a given point when you're designing, engineering your batteries in the beginning itself, so for the first life, which in different cases would be different from 3 to 7, 8 years, 10 years lifetime, it will be used in automotive. Post that, acting as an energy storage solution, and post that in the third life as a power backup solution. So one can easily get a 15 to 20 year life cycle depending on the chemistry we use and the issues which we are addressing there. And then the issue of battery recycling and mining actually come into play. And that is where energy becomes extremely critical. And not only that, On the other end, this also helps us to ensure energy security as a country. Today, we are dependent for our energy resources. More than 85% is imported from different parts of the world. And a huge sum of money, a largest part of our GDP actually goes towards that. So I think it is imperative that how we work towards energy security. And one stream is electricity, which we look at today, right? Where we talk about green energy being produced in form of solar, hydro, or many other resources. Electricity is produced, and that is what should be used. And across all sources, all different organizations are actually having green buildings. They are producing, having green products, green factories, which are using forms of green energy in this case. The second stream is that today as a country, we have about 6% of energy mix coming from gas, which we endeavor as a country in next 10 to 15 years to move to 15% energy mix of gas, which is about 2.5 times of where we are today. And that's why there is a great program which is launched, which by Ministry of Petroleum and Natural Gas, where you talk about bio CNG, compressed biogas, and other things, and which will again be a constant stream alongside electric as we go along. And clearly, having a complete gas ecosystem there, where we are having green gas, we are consuming different types of waste, we are consuming multiple kinds of issues which we face in India. As a country, we generate about 62 million tons of waste every year. And if we are able to see that, we are able to move towards even 50% of it getting consumed and moving to a zero waste structure. And here I'm only referring to food waste, agriculture waste, municipal waste. There's a lot of electronic waste and many other medical hazardous kinds of waste which have other issues. And it will become a circular economy, creating multiple opportunities, which is the idea here. And there would be parallel streams running where, and especially where we are sitting in Delhi NCR, northern part of India, we have a huge issue of stubble burning in the winter season, and so which is parali burning from the crop waste which is created, which can easily be converted into bio CNG and compressed biogas, which is nothing but a more compressed form of energy which we use. And on the other hand, when you are able to see that energy flows into such kind of vehicles, and as my other co-panelists were mentioning, if you have energy efficient systems which are there in the vehicles, you would reduce the parasitic losses substantially, and you would see that the energy efficient systems are able to either draw more power, create more autonomy in the vehicles, which depends directly to the weight of the vehicle and the other aggregates you have which are driving the vehicle, or you would be able to save cost and make them more competitive. Because the idea is that how you are using these solutions across the EV ecosystem to enhance competitiveness through excellence.
Yeah.
So when you're driving competitiveness, there the point comes out to be that clearly technology is driving value. And in such a scenario, you would see that the requirement of subsidy or any such initiatives only act as a catalyst to create the inertia. And then the market has to be self-sustainable, where solar was 10 years back. Right. And today we all know what kind of journey India has embarked in solar, right, becoming the global headquarters. So I think that is what is important. So cutting across the ecosystem, whether you talk about the EV, starting from generation to consumption, or the gas ecosystem, where we see that as an inclusive growth objective, the industry is actually working across different spheres of businesses.
And talking specifically about your investments in the renewable energy, what's the kind of capacity you have currently, and what's the projection that you have?
So we already have more than 200 megawatts of capacity in renewable energy only in the solar space. We are building a very large facility for energy storage also, and in the green CNG and compressed biogas also, and waste to energy as well, where we consume waste from multiple cities and then generate power. So I think it is very important that we as an organization are focused on sustainability, and that's where the majority of the investments are going, and we would be crossing a gigawatt hour in the next few years itself. So idea is that across all the facilities where we are doing electric vehicles, buses, or charging systems, or our battery packs, how we are carbon neutral to the maximum extent possible, and how our systems are most energy efficient as well today. Right. So that is the whole idea, so that we are operating across the ecosystem.
Dr. Subramanian, sustainability is now a key cornerstone of all strategies by almost every responsible organization. At Ashok Leyland, how are you leveraging the inherent strength of the Indian ecosystem of frugal engineering to come up with solutions which are definitely energy efficient, cost efficient, is almost a given when it comes to Indian engineering, but also sustainable, highly sustainable.
I think we are very excited about the Indian ecosystem in Jugaad, and that's the other Indian word for Indian engineering, right? So we have a model for any innovation. We have a combination of internal development, external partners, academic institutions, supplier partners, all of whom are encouraged to work in this fashion, in a very agile fashion, all of that.
How big is the engineering team at Ashok Leyland now?
It depends on how you count, but it's about 1,000 plus. And within that is another team called Advanced Engineering, which is looking exclusively at future problems in powertrains, in electronics, in advanced
Which is what
materials,
we're-
in analytics.
Yeah,
Yes.
which is what- So when you look at that, the little bit future gazing, how do you see the powertrain mix changing for the commercial vehicle industry?
Yeah, there's no clear answer because there are too many options today. We know the future is not petrol and diesel, but what it is not an obvious answer. There are biofuels, there is CNG, there is LNG, there is hydrogen IC engine, there is hydrogen fuel cell, there is all the way up to battery. There are biofuels, there are also any combinations of these, right? Because today, if you pick any one of these, I'm talking truck segment, any one of these, seems to be no clear commercially viable answer. So none of them is on its own commercially viable. Therefore, a smart combination may be viable, right? So what we are doing to get ready is we are building a completely modular platform where the same building blocks can be used to make any powertrain, any fuel, right? So that's something we are working towards, and that's a very solid dream for us. It's something that we are executing as we speak. That if when a customer, because we are one piece of the puzzle,
Yes.
right? The government policy is another piece, other big players creating the infrastructure, whether it's hydrogen, whether it's some other fuel,
Then
that's
you have
another
customer
piece.
requirements.
Right. Customer requirements is another piece. So we are one piece of the puzzle. So we have to be ready for everything, right? And the only way to be ready for everything is to make this modular architecture of building a vehicle where you can, when the time comes, when there is a customer who says, I want a battery fuel cell hybrid, maybe, I'm just thinking wildly here, then we will have the ability to make it because it's all just the building blocks, right? And so we are very close to having that modular platform with us. Yeah.
Again, I'm just thinking aloud. Could it be one of the solutions be a multi-fuel powertrain also?
That also is something we are working on. There is, in fact, a company here which gave me a business card which is talking about multi-fuel powertrains. I don't know how multi-fuel it is. I have to talk to them, but multi-fuel, it was a multi-fuel IC engine. I'm doing free publicity for somebody here, but, but then, yeah, I think
such a
that's the
project is
trend.
also
But
taking shape at
we are
Ashok
saying
Leyland.
multi-fuel all the way to the extent of non-IC engines as well,
Oh.
and hybrids as well. So IC engine-based multi-fuel, fuel cell systems, battery systems, and combinations of these built in a modular fashion. Right?
That's interesting, Dr. Jaura. Multi-fuel vehicles, so how feasible would they be in the Indian context? And or let's take a step back. How feasible, how challenging or easy would it be to kind of commercialize them?
I think multi-fuel vehicles are not new again in the industry. OEMs have done that in the past as well, where you actually can have a mix of fuels as well. Hythane, for example, is one of them.
Yeah.
Okay, and these vehicles have been done by my earlier stints here in India as well as overseas. So, and with a flip of a switch, you can change it between a CNG versus a gasoline or a diesel vehicle. But having said that, the cost to do such a vehicle and the hardware to do such a vehicle is something that limits
That's what
where you want to go.
Yeah.
Okay, because technology and innovation can do a lot of things, but what do you bring to the marketplace that makes sense to the market? When I say market, also the customers, of course, is something that is a balanced decision between business and in terms of engineering and technology, as well as in terms of the holistic environment. One could build a vehicle if you don't have the ecosystem. then how do you sell it in the marketplace? I mean, how would you buy an electric vehicle if there are no charging stations, for example? Or how would you actually recycle the batteries if you build so many other vehicles? So these are things that you have to sort of build in sync. So the energy companies, the government, the OEMs, the customers, everybody has to come to the table and decide what they want. We cannot be like the kids in the candy store where we want to touch and take everything in our pockets. And that is where we as humans are looking at various things. And as OEMs, it's our responsibility. It's also our corporate social responsibility to make sure that we look at the sustainable solutions and the sustainable environment. And I think when we look at it, step back and look at that, I think that is a success story for everybody. So I'll stop at that. It's doing.
Yeah. No. But what the next big thing at least in your current organization is the move towards the electric, right? So how are you? What steps, what factors are you kind of putting in place to ensure that it's more sustainable than just being going tailpipe emission free and having it kind of really making on contribution towards the ultimate goal of.
Absolutely. So if you look at Hero as a company, I mean, we actually not just talk about sustainability, we also walk the talk when it comes to sustainability. Now, if you just kind of rewind 2 months ago, where our chairman, Dr. Munjal, had announced at the unveiling of the Vita brand, we're also putting $100 million as a sustainability fund towards doing things. If you look at our plants, they're green plants. I mean, I don't know if you've got a chance to visit the Nimrana plant or the global GPC and other plants. I mean, they're green plants. Literally, the plant breathes. So you have to actually visit it, see it, and believe it. That's from a complete, I would say, manufacturing perspective also, because we want to do end-to-end. Then in terms of, we talked about solar, renewable. You look at CIT, the Center of Innovation and Technology in Jaipur. We have been using solar energy in the facility for many years. And we're augmenting that a lot more every year. Year by year, we're doing that. Now coming to electric vehicles, yes, I mean, that is one of our very big strategies. It's one of our big levers. And you have seen the announcement in the news on the electric vehicles that there's a lot of thrust. We have built an array of plans in terms of what we will bring into the marketplace. When are we going to bring it? Not only just the vehicles, but also in terms of cell chemistry, in terms of what can actually take in terms of segmentation. Whether we're talking about a very high performance electric vehicle, or we're talking about a commuter bike or a scooter or things like that. So that is a mainstream strategy for us besides what we do. I mean, we've been in the business of being at the top for the last 20 plus years. And we want to continue doing that, and not from the positioning of that, but also to be able to offer to our customers what they want to drive or what they want to ride.
Right.
And that's why I'll leave it at that. Thank you.
And with that, we come to the last part of this session, and which is an interactive session with the audience. So anyone who has a question, kindly raise your hand. The mic is reaching you there in a couple of seconds, and please introduce yourself. And
hi, myself is Sheetal Joshi from ANSYS, and my question is for Mr. Subramanian. You nicely gave an example about primary and secondary effects on the losses, and in terms of net zero energy technology mix. Does that mean towards making a better regenerative, because driver habits is a more individualistic choice, but regenerate, does that mean that technology?
I think both, because I think we will need to control the driver through the electronics in the vehicle.
All right.
So the driver thinks he is in control. I don't know if it's the right thing to say, but the controller actually is doing a lot of stuff behind his back.
Got it.
Right? Which, as one example I gave, limits acceleration. Right? The other side of the same coin is regenerative braking. Unfortunately, with regenerative braking, efficiencies are low today. And if you turn on a very large amount of regeneration, then the feel is a lot less. So that's what I meant, if the heat sink example in electronics.
Got it.
You stop the problem at the source. If you can limit acceleration and therefore consequent braking in the first place, then you have to deal with a much smaller problem, right?
And
Regeneration is handling the problem after
applicable
it's happened.
for fleet operators or commercial. It may be more enforceable as compared to passenger vehicle.
I think people will get used to it. Yeah.
Okay.
Yeah. There's a lot of driver assistance systems also coming.
Yes.
right? Which will all aid in largely safety, but I think they will also can be made to aid in efficiency. Because once you have a front camera and once you have a very Indian driver assistance system, for example, looking at potholes, looking at speed breakers which are not painted as per the standard and so on, you can plan for that event, right? Rather than giving a last minute jerk, right? So that also adds to efficiency, right? Also very simple things, the move to automatic transmission, or the technical term being AMT, automated manual transmission. So you still have the clutch and gearbox, not the conventional hydraulic manual automatic transmission. So the automated manual transmission, right, which is today seen as a little expensive thing, we are working on bringing it to a very low cost. So if we can give that on commercial vehicles, buses and trucks, then it straight away increases mileage, straight away increases things like clutch life dramatically, because you don't have manual pressing of the clutch at all. You have a very smooth on and off of the clutch. So a lot of even simple things like that, right, which will arrest the problem at the source and not generate a lot of emissions in the first place.
This is Saurabh here, and this is a August session with all foray of means from two-wheel to buses and trucks, and you from component and OEM both sides. Last century has been, as you talked about the puzzle, last century has been the car makers or the OEMs and the petroleum company per se as the big guys, the two. And with evolving, say, new energy and net zero concepts, there are different puzzle players coming into picture. Let me say software or digital and multi and many more. Of course, last 100 years, OEM were playing the shots. Consumer is the king, I know. Customer is the king. But whom do you see playing the shots in future with the evolving transition to different new energy scenario?
Dr. Jaura,
And this is to...
I think they say the biggest competitor to the transportation industry is the video conferencing software, right? So there are new competitors. Your point taken, but whoever wants to take the question.
No, I think, see, the biggest thing which happens now is that earlier always it used to be a need or a choice. Now it's all about an experience. So the experience will redefine the comfort and how the comfort is being driven towards delight for the user. And I think that would have multiple aspects, how one is able to customize that experience, because for every user, comfort and delight means something different. So how that can be provided in different forms, and obviously there are many substitutes as we heard as well. But at the same time, agility and frugality is something which would be essential in redefining and defining an organization's experience in a product for a specific end customer at all times. So how many fractions, how many such solutions can one create and really position ourselves in the fastest time to market is what would be the winner eventually. And there would be no winner because you always have to be on your toes on a constant basis, and there's something disrupting and redefining the market conditions again.
Last word from you.
You know, we used to talk about TCO, total cost of ownership. Now it's OCE, overall customer experience. And it's just not about ride comfort, not about cabin comfort. It's about comfort of owning a vehicle. If I have a vehicle, it's not just riding from point A to point B. It's how easily can I service it? How easily can I refill it? How easily it's accessible? And the security features. And you talked about digitalization, artificial intelligence. These aspects are going to be enablers, because today's customer is very impatient, including myself. I'm a customer, you're a customer, everybody in the room is a customer. So we are impatient because everything is available on a palm. You know, anything you need, you just Google it or whatever, you get it. So we are looking for features, and that brings back what Nishant said. You're talking about agility, how fast can you come there? So everybody is going to play a big role, and it's not going to be customer calls the shots or the OE calls the shots or the stakeholder calls. It's all, we are all going to go do it together, and we'll win together. Thank you.
Well, on that note, indeed, well
Okay,
said.
I have one question here.
Okay. Keep it really brief. We take it.
Right, this is to Dr. Arun. How much of the design philosophy in vehicle building is cradle to cradle? Because typically I see electric vehicles, so-called green, has more plastic parts than what you see in a conventional IC engine two-wheeler, right? My name is Anjan. I represent Green Design Technologies. We are an electric vehicle company as well. Yeah.
You know, there are recyclable plastics as well. Okay, so you can actually make plastics that are more user-friendly, more environmental-friendly. Having said that, if you look at the battery storage box, it's plastic, yes. The fuel tank is also plastic these days, right? So if you compare energy apples to apples, yes, that is, we are replacing the plastic fuel tank with a battery storage box which is plastic. Other than that, I think the plastic content in a vehicle is not very different. At least in a two-wheeler, I speak of two-wheelers now. I'm not even going to speak about four-wheelers, six-wheelers or whatever, okay. But in the two-wheeler space, the plastic that I use in a fuel tank, I use it in the battery storage. All my fairings that I have around the vehicle are the same. I can use composites, I can use lightweight materials, I can use other kind of plastics, or I can also use recyclable wood dust material to make these. The frame, of course, is metal, and there are different kind of metals that we can talk about. Engine is an engine. And the seats also, we have recyclable material in the seats. We also have seat covers, which are temperature sensitive. So we have actually developed as Hero a technology where you park a vehicle in the sun. Typically, what happens is in a hot day, the temperature of the seat is at least 70 plus. So we have actually worked with stakeholders, with like-minded people to develop materials where your seat, when you actually go touch your seat and your bike has been sitting in the sun for 2 hours, 3 hours, hot soaking, it's about 50. So the discomfort in sitting on a vehicle and driving or riding a vehicle is drastically lower. And that is a recyclable material as well. So I'm going to leave it at that.
Indeed. So the target net zero solution doesn't end only at the fuel tank or at the powertrain, but it's at the entire vehicle and also the entire ecosystem. So on that note, gentlemen, thank you very much for sharing your insights, your the various perspectives, which, as I said, extremely very rich food for thought. So on that note, it brings us not only to the end of this session, but also to the end of the third edition of the ETAuto Tech Summit. And a big thank you to all the audience for your patient listening, participation, your interactive sessions. Big round of applause to all of you. Thank you so much. Thank you so much.